Hi, welcome to another video in my series on solving differential equations. And in this video what I'm going to show you is how we can develop a differential equation from a written problem, and it also involves direct proportion. So we've got here the rate of increase then of a certain population P at time t is directly proportional to the population P at that time t. And we're given that P equals 4 when t equals 0, and also that P equals 8 when t equals 1. And we've got to find the value of the population P when t equals 3. Well, to do something like this, we've got to just set up the fact that we're told that the rate of increase of a certain population P at time t is directly proportional to the population P at time t. We write this as dP by dt. That's the rate of change of the population P at time t, and it's proportional to the population P at that time. Now when we have proportion, we need to change this to an equal sign and involve a constant. And so we would change this to dB by dt equals a constant, let's call it k, times the population P. Now, what we've got to do is solve this differential equation. And we do this by separating the variables. And we can see now that we can divide both sides by p and remove the dt, and we get 1 over p dp equals k dt. And we must integrate both sides at this stage. So we integrate that side and we're going to integrate that side there. So what do we have here? Well, the integral of 1 over p with respect to p is going to be the natural log of p. And for the integral of the constant k with respect to t, well, that's going to be kt. Now in the past I've shown you that you have a constant from here and a constant from here. If we take away the constant from this side to the away from the constant on this side, we just get a general constant. Let's call it c. So there's our equation now. In fact, we don't really need the mod sign because the population P is going to always be positive, so we don't really need that mod sign. Now, to work out these constants, we've got to look at these initial conditions up here. And we'll take the first condition. When t equals 0, we know that p equals 4. Let's just write that in here. When t equals 0, we're told that p equals 4. And we can substitute this into this equation, and therefore we have the natural log of 4. As I say, we don't really need mod signs down here because it's a positive quantity. And then it equals k times 0. Well, that's going to be 0. And then it just leaves us with c. So you can see that we've got the constant c is the natural log of 4. Well, if I call this equation 1, then if we just come down here, alright, and we sub that constant c, natural log of 4, back into 1, let's just say that we'll sub into equation 1, then we've got the natural log of p, so therefore natural log of p, I won't write the mod signs now, equals kt plus the constant c, which we've just seen is the natural log of 4. Now we could simplify this. We've got 3 terms here, 2 of which are logs, so we need to bring those 2 terms together. So we've got the natural log of p minus the natural log of 4 equals kt. Just subtract natural log of 4 then from both sides. Now when we're subtracting 2 logs, we can simplify this to the natural log of p over 4. Okay, the subtraction rule. for logs. And then this is going to equal kt. Now at this point we can work out what the constant k is by using this second boundary condition. So we'll just write that in, that we know that when t equals 1, p equals 8. And if we substitute this into here, we therefore have the natural log of p, which is now 8, over 4 equals k times t, k times 1, in other words just k. So we can see that therefore the constant k must equal the natural log of 2, 8 divided by 4. Okay, so let's call this equation down here equation 2, and we can substitute into that equation the value that we've just now found, k. So we can say sub into equation 2, and therefore what we've got is the natural log then of p over 4 equals k times t. Natural log of 2 multiplied by t. Now I don't want to write that because that looks like the natural log of 2t. So I'm going to put the t at the front here. So we'll just rub that out and we'll put t there. Now I've got two terms, but we've got this t in the front of the natural log. So in order to simplify this, I'd need to get rid of this t, and we can use the power rule for logs. Okay, we can change this to the natural log of p upon 4 equals, and we just bring the t up as a power, so it becomes the natural log of 2 to the power t. So now we've got our two terms, both terms are natural logs. We can anti-log, and that means that we get p over 4 equals 2 to the power t. And if we multiply through by 4, both sides by 4, we therefore have p equals 4 multiplied by 2 to the power t. It's not 8 to the power t, a common mistake I often find when doing questions like this. Just 4 multiplied by 2 to the power t. So now we can answer the question, find p when t equals 3. So we can say that when t equals 3, p must equal 4 multiplied by 2 to the power 3, 2 cubed. 2 cubed is 8, 4 times 8 is 32. So we end up with, therefore, p equals 32. Okay, so I hope that's given you an idea then how to do or form a differential equation, especially when it is about direct proportion. We set up this, okay, and then we introduce our constant k, and so we get, in this case, dp dt equals the constant k times p. We then separate the variables and then solve the equation using our initial conditions or boundary conditions to work out the constants. Now in my next example I will do a similar question to this, but we'll look at inverse proportion. Quite often you get questions like that on inverse proportion, and I'll show you how to handle that type of question. And don't forget, it's always a good idea to look at my videos on my website rather than my YouTube channel, because on my website it's got a full index and lists of various examination boards, the specifications that go with them. So it's generally easier to find what you're looking for on my website. Okay?